Hey, I'm no machinist. I've got this shaft out of a swather. It was all torn up, and I took it to a machine shop to have them turn the taper on this end and tap it. And what I've got left to do is a keyway here and a woodruff key on that end. I'm going to do the long straight key. Now it's a keyway. It's 7 inches long, which is, well, it's kind of ridiculous, but that's the way it is. My mill's a step pulley mill. They should run around 1,000 RPM from what I understand on these edge finders, but the closest I can get with my setup is about 1,200, so it's just, that'll work. We'll just pull the table in until we make contact and it kicks out. Okay, I've found the edge there. Let's crank her up, crank her down, so we can clear the workpiece. Now I need to actually find the center of the piece. The edge finder mic'd out at 376 thousandths. Divide that by 2. It's 188 thousandths. That's your radius. You've got an 1¼ inch shaft. That divided by 2 is 625 thousandths. So we need to move 813 thousandths to the center. Okay, let's go ahead and zero. Looks like okay, I'm zeroed right now. Okay, I've got to go 6 revolutions, gives me 750 thousandths. There's 1, 2, 3, 4, 5, 6. I misspoke. It should have been 750 thousandths. I think I said 650. Okay, we're at 750 thousandths. Now we need another 63 thousandths to get there. Okay, there's 10, 20, 30, 40, 50, 60, near as I can tell, that's 63 thousandths. I'm not wearing my glasses. Just these video glasses. I'm off. I'll take it off after when I'm switching cutters, just to make sure I'm where I'm at. Okay, so now we know that the spindle is centered over the shaft. I don't worry about tool offset or anything like that. I guess you can, use the proper semantics, but all I care is that I'm centering. The spindle is exactly centered over that shaft. Okay, I'll go ahead and switch to a cutter and we'll go from there. Now I need to find the top so that I can set a depth. Now I'm going to use 2 cutters. I'm going to use a 3/16 and a 1/4 inch cutter. The final key width is a 1/4 inch. And the reason I found with this machine anyhow, if I start out with a smaller mill, remove most of the material, and then go back with the final 2 size mill, I don't have as much deflection. I don't get as wobbly a cut, and my tolerances seem a little better. I was looking up some specs on these, and everything I could find says there's, the stuff that's out there, they specify that they have 0 to +2 thousandths tolerance on a lot of these shafts. For this kind of application, obviously this isn't, it's not the space shuttle. So I mean, I've got a little leeway, but I find that I like the fit. I mean, I'm doing everything by fit, and if it fits tight, I'm happy, and I find I get a good tight fit doing it this way. Okay, so we'll find the let's touch off on that. All right. All I'm going to do is look to see where it starts cutting. Just kiss it. There we go, right there. You can either hear it or see it. See that small line there? Okay, we're good. No backlash. Turn it off. Now I'm going to zero it out. Okay. I guess that's right. I can't see it. Hold on, I'm going to put my glasses on and see what it looks like. Okay, yeah, I'm at 0. Okay, now the specs on these Gib keys are different than a straight key, straight square key. Gib key has a taper on it. It makes the whole assembly tighter when you bang it in there. Most of the specs I've seen are 138 thousandths inch depth for a 1/4 inch key on the shaft, and a corresponding something like it on the hub. I forget what it is because we're not concerned with the hub. And I couldn't figure out why I was only showing about 100 thousandths in depth on the wide end of the hub. I thought, well, something's wrong here. Maybe I need to go deeper. Well, I didn't fully understand Gib keys. I mean, I've worked with them, but I didn't know the actual machining. All it is just a wedge, and it's set up tight. Now, on the Gib keys, you can go down as low as 142 thousandths, and I think I forget the tolerance on that. So I'm probably going to split the difference and probably go 140 thousandths. With the caliper, I'm showing the keyway and the hub to be about 95 thousandths with a inside gauge, and micrometer I'm showing it at about 102 thousandths. So if I go 140 thousandths plus 102 thousandths, that leaves me with 242 thousandths, still enough for an interference fit. And if I can't find the correct keyway, well, I can always doctor or key. I might have to go with a square key. I've still got 10 thousandths in crush, I guess you'd call it, on that key. So anyhow, that sounds kind of convoluted, but that's one of the considerations. But anyhow, I'm going to start out with a 3/16 mil, and I'm going to go down 135 thousandths on it, and I'll finish up at 139 or 140 with the 1/8 inch mil. So I guess here we go. I'll make sure everything's locked up. All right. And there's my mark right there. That's where I stop. I mean, it's not anything precision. You just got to be in the area. I'm hoping with a relatively slow speed I'm going to get a minimum of deflection on the machine or the mill, the actual end mill, and I won't break my end mill. With this machine, I don't know about better ones, but with this machine I found there's a lot of deflection. Like, let's say I tried to go a straight 1/4 inch end mill on, just a single cut. You put that key in there and you got a lot of slop, so that tells you you're getting a lot of deflection. I hope I'm not cutting chips. I probably am. I don't mind stopping on this first cut, but I sure wouldn't want to stop on the finish cut. Need to continually feed it from what I gather. And I've also noticed when you stop, you get a divot. And that divot shows you just how much you're deflecting. Because you know, it's crazy. On one side of that mill, you're climb milling, and on the other side, you're conventional milling. And the overall is, you know, you're going to have some movement. But, I mean, it's just rotational force. Radial force, I guess they call it. And it's going to want to slew that thing offline. Get rid of this thing. I don't know where to put it. Let's put it down there. And I've also left the final depth to cut, you know, for the finish cut. This is a 4-flute end mill, and I'll do the finish cut with a 2-flute end mill. Because I've heard and read, and I don't know whether it's true or not, that those, they're a little bit better for cutting keyways and slotting. Because 4-flute is a end cutting mill. And hold on, I gotta take these off. Yeah, okay, I need to know where I'm at. I'll go a little bit beyond. There we go. And I'm just going to shut it off. If you run this backwards through there, you'll change your dimensions. So you're better off just running one way, shutting her down, then backing her out. Okay, I'll change cutters and do the final cut, I guess.